Hello students. So today in this video we will discuss our class 9 first chapter, that is the number systems, and we will be solving the questions from exercise 1.3. So let's see what is the first question. Write the following in decimal form and say what kind of decimal expansion each has. So here 6 questions are given and all these are examples of the rational number. And we know that the decimal expansion of the rational numbers can be either terminating or non-terminating repeating. Now let's see, these questions will have what kind of decimal expansion. So the first question is 36 by 100. It is a very straightforward question since in the denominator 100 is there. So this can be written as 0.36. Because in the denominator 20 is there, so that is why the decimal point will go before 2 digits. So here clearly we can see that after the decimal point the digits terminated. So it is an example of the terminating decimal expansion. Now the second question. So 1 by 11. Now this one, to check whether the decimal expansion will be terminating or non-terminating, we have to divide this number. So see, 1 is divided by 11. So decimal point 0. Again 10 is not divisible by 11. So we have to put one more 0. So 11 9s are is 99. Again 0. One more 0. 11 9s are is 99. Again 0 0 9 9. So if we continue, we will find that if we divide 1 divided by 11, we will be getting 0.0909090909. So the digits will not terminate. So these two digits 0 and 9 will be repeating. So this one can be written as 0.09 bar. So above the 2-digit bar is there, that means this set of digits will be repeating. So this kind of decimal expansion is called non-terminating repeating. So what kind of decimal expansion it is? Non-terminating repeating. Or we can say that non-terminating recurring. Now let's see the next question. So see, the third question is 4 1 by 8. Now it is given in the mixed fraction. First we have to convert into the normal fraction. So how to convert? So 4 multiplied with 8 and then we have to add 1. So 4 8s are 32. 32 plus 1 is 33. So 33 divided by 8. Now divide 33 by 8 and check what kind of decimal expansion we will get. So when the 33 is divided by 8, 4 8s are 32, 1, decimal point 0, 8 1s are 8, 2, 0, 8, 2s are 16, 4, 0, 5 8s are 40. So here you see we got the remainder 0. That means here also we can see after decimal point the digits got terminated. So this kind of decimal expansion is called. So when we divided 33 by 8, what we got? 4.125. That means the decimal expansion is terminating. Now the fourth question. Fourth question is 3 divided by 30. So again, first we have to divide and check. So decimal point 0, 13 to the is 26. So 4, 0, 13 3s are is 39. 1, 0. So 10 is not divisible by 13. So we have to put 0 here, 0 here. So 13 7s are is 91. Then 9, 0, 13 6 are is 78. So 12, 0, 13 9s are is 117. Now what we got? 3. So see, remainder we got 3. So it is divided by 13. So this one I am continuing. So here 0, 13 2s are is 26, 13 3s are is 39. That means if we divide 3 by 13, then we will get the digits 2, 3, 0, 7, 6, 9. Again, after this 9, the digits will be repeating. Again, we will be getting the digits 2, 3, 0, 7, 6, 9. So if you continue the divisions, you will be getting this set of digits. That is 2, 3, 0, 7, 6, 9 will be keep on repeating. That means when we divide 3 by 13, what we'll get? 0.230769230769 dot. That means 0.230769 bar. That means these sets of digits will be repeated. So what kind of decimal expansion it has? So this kind of decimal expansion is called non-terminating repeating. Non-terminating repeating. Now let's see the next question. So question number 5 is 2 divided by 11. 2 divided by 11. So let's divide 2 divided by 11. So 11 ones are 11. 8 11s are 88. Again 11 ones are 11. 11 8s are 88. So if we divide 2 divided by 11, we will be getting 0.181818 like this. So these two digits 18 will be keep on repeating. So what we will get? 0.1818 like this. So this one can be written as 0.18 bar. So above the 2-digit bar is there. That means this 1 also will be repeating, 8 also will be repeating. These two digits together will be repeating. So what is the name of this kind of decimal expansion? This kind of decimal expansion is called non-terminating repeating or recurring. Non-terminating repeating. Now let's see the last question, that is 329 divided by 400. Okay, now let's see this question number 6. So 329 divided by 400. Now to make this calculation simple, directly we will not divide 320 by 400. So this can be written like this: 329 divided by 4 into 1 divided by 100, because 329 into 1 is 329 and 4 into 100 is 400. Now let's divide 329 divided by 4. So 4 8s are 32, 4 2s are 8, 4 2s are 8, 4 5s are 20. So here we got the remainder 0. So when we divided 329 divided by 4, what we got? 82.25 into 1 by 100. So this one we can write 82.25 divided by 100. Now here you see in the denominator 20 is there. So that is why this decimal point will come before 2 digits. So this will be 0.8225. So here also we can see that the remainder we got 0 and the decimal point and the digits after the decimal point terminated. So this kind of decimal expansion is called terminating decimal expansion. So from this what we can conclude, the rational numbers can have only two type of decimal expansion. Either it will be terminating, or if non-terminating, then it will be obviously repeating. Now let's see the question number 2. You know that 1 by 7 is equal to 0.142857 bar. That means this, when we divide 1 by 7, this set of digits will be repeating. The 6 digits will be repeating. Now according to this question, can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are? But the condition is given that we are not allowed to do the long division method. Without directly dividing, we have to tell what will be the decimal expansion of 2 by 7, 3 by 7 and so on. So let's see how we can do this thing. So in the question it is given 1 by 7 is equal to 0.142857 bar. Now we have to tell the decimal expansion of these rational numbers, but we are not allowed to do the long division method. So let's see how we can divide. So see 2 by 7. So this 2 by 7, how can we write? 2 into 1 by 7. Obviously it can be written like this because 2 into 1 is 2 divided by 7. Now you see 2 into 1 by 7 value already given in the question. What is given? 0.142857 bar. Now multiply this value with 2 and we will get the decimal expansion of 2 by 7. So see 0.142857 multiplied with 2. 7 to the 14, 5 to the 11, 1 carry, 8 to the 16, okay, 17, 1 carry, 2 to the 4, 5, 4 to the 8, 2 ones are 2. That means these sets of the digits will be repeating. So what will be the decimal expansion? 0.285714. These digits will be repeating. So the decimal expansion of 2 by 7 will be 0.285714. Since these sets of digits were repeating, so obviously these sets of digits also will be repeating. So in this way, we can find out the decimal expansion of 3 by 7, 4 by 7, 5 by 7. So see, next is 3 by 7. So 3 by 7 also how can we write? 3 into 1 by 7. So 3 into 1 by 7 value is given 0.142857 bar. Now multiply this value with 3 and we will get the decimal expansion of 3 by 7. 0.142857 multiplied with 3. So 3 7s are 21, 2 carry, 3 5s are 15, 17, 3 8s are 24, 1 5, 2 carry, 3 2s are 6, 7 8, 3 4s are 12, 1 carry, 3 1s are 3 and 1 4. So the decimal expansion of 3 by 7 will be 0.428571 bar. Now let's see the decimal expansion of 4 by 7. So 4 by 7 will be 4 into 1 by 7. So 4 into 1 by 7 value is given 0.142857 bar. Now multiply this with 4 and we will get the decimal expansion of 4 by 7. 0.142857 to 4. 2, 20, 22, 2 carry, so this will be 0.571428 bar. Now 5 by 7. Same 5 by 7 also same. 5 into 1 by 7. So 5 into 0.142857 bar. 5 7 ja 35, 3 carry. 5 5 ja 25, 28, 2 carry. 5 8 ja 40, 42, 4 carry. 14, 1 carry. 4 5 ja 20, 21, 2 carry. So this will be 0.714285 bar. And the last one is 6 by 7. 6 into 1 by 7. So 6 into 0.142857 bar. So multiply this with 6. 6 30, 30, 34, 3 carry, 48, 51, 5 carry, 7, 1 carry, 2 carry. So this will be 0.857142. So in this way, without dividing the actual division, by looking at this value, we can find out the decimal expansion of all these rational numbers. Okay, now let's see this question number 3rd. Express the following in P by Q form. That means rational number is given in decimal expansion form. We have to convert into fraction form. That is P by Q form, where P and Q are integers and Q should not be equal to 0. So in the first question, we have discussed that how we can convert the rational number into decimal expansion form. Now this decimal expansion here, all the decimal expansions are non-terminating repeating. Here you see 0.6 bar, that means the digit 6 will be repeating. Here you see 0.47 bar, above the 7 bar is present, above the 4 bar is not present, that means this 7 digits will be repeating. Here in this question 001, here these 3 digits will be repeating. Here this 5 and 4, 5 and 4, both the digits will be repeating. Here whatever examples are given, all these are examples of the non-terminating repeating decimal expansion. So this non-terminating decimal expansion, how we can convert into the rational form, that is the P by Q form. So there are different methods we can, by different methods we can solve this. So first we will discuss the long method, then I will show you how to solve by shortcut method. So the first question is 0.6 bar. So let x is equal to 0.6 bar. Now this, what does this mean? This means that this 6 will be repeating. Now multiply both the sides, left hand side and the right hand side, both the sides multiply by 10. Multiply both the sides, multiply both the sides by So see, if you multiply the left hand side with 10, we will get 10x, and if you multiply the right hand side, then what we'll get? This one digit only. Since we multiply with the 10, so one digit will come before the decimal point. So this will be 6.666666 like this. Now you observe both the equations. For example, this is equation number 1 and this one is the equation number 2. So in this equation also you see after decimal point the digits are same. Here also after decimal point the digits are same. Now subtract the equation 1 from 2. Now subtract equation 1 from 2. So if we subtract the equation 1 from 2, what does this mean? 2 minus 1. So left hand side subtract 10x minus x, and right hand side what is given? 6.666666 minus 0.666. Now you may think that since these digits are non-terminating repeating, so how can we subtract these digits? The subtraction is very easy. So see 10x minus x, that means 9x. Now how to subtract this one? So see, very easy subtraction. So 6.66666 like this minus 0.666666 like this. Now you see, if you subtract 6 minus 6, 0, 0, 0, like this will be getting, and 6 minus 0, 6. That means what you will get? 6.0000. So this will be what? 6 minus 0. That means 9x will be equal to 6. Now x is equal to 6 by 9. If we simplify, 3 2 are 6, 3 3 are 9. So see, how can we convert 0.6 bar in the p by q form? So we got 2 by 9. So the non-terminating repeatant decimal expansion also can be written in the form of p by q form. So this is the long division method. This is the long method. In this way, the non-terminating decimal expansion also we can convert into the p by q form. Now, in this way, this is the long way to convert the non-terminating decimal expansion in the p by q form. So if the question comes for 2-3 marks, so this all steps we have to follow. But if the question comes in the form of multiple choice question, so we don't have that much time to find out the answer. So for that we need the shortcut method. So let's see. Shortcut method. So see 0.6 bar. Now see, if above the one digit bar is there, so in the denominator we will be writing 19. If above the 2 digit bar is there, then we will be writing 29. If above the 3 digits bar will be there, then we will be writing 39. And here whatever numbers will be left, this will be writing in the numerator. So this will be 6 by 9. So 2, 3. So this one is the shortcut method. So if the question comes in the form of MCQ, then we can use this shortcut method. Otherwise, we have to use this long method. Now let's see the question number 2. So the question number 2 is 0.47 bar. So in this question clearly you can see that above the 7 only bar is there. That means only the digit 7 will be repeated. 4 is not repeating. So let x is equal to 0.47777 like this. That means only the digit 7 is repeating. Now the same method, multiply both the sides by 10. Multiply both the sides by 10. So this will be x into 10 is 10x. So this one if you multiply by the 10, then this one digit will be coming in the left side. So this will be 4.7777 dot 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 dot. Now see, here we can see that 0.477 is there, here 4.777 is there. That means after decimal point the digits are not same. So after decimal point, if you are not getting the digits which are same, then you have to keep on multiplying the equations by 10. So again multiply both the sides by 10. Now you see, this one if you 10x into 10 will be 100x. Now this one also if you multiply with the 10, again one digit will be coming before decimal point. So this will be 47.7777 like this. Now you check, are you getting any two equations where after decimal point the digits are same? So here you see, after decimal point 0.477 is there, here after decimal point 77 is there, after decimal point 77 is there. That means these two equation we can take because after decimal point the digits are same. So this one we can consider as the equation number 1 and this one we can consider as the equation number 2. Now we will subtract the equation 1 from 2. Now subtract equation 1 from 2. So equation 1 from 2, what does this mean? 2 minus 1. So 100x minus 10x is equal to 47.777 dot 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 minus 4.777 like this. Now 100x minus 10x, 100 minus 10, 90x. Now this one if you subtract, this subtraction just in the first question we have discussed, no, this subtraction is very easy. See, 47.777 dot 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 minus 4. So see, 7 minus 7 0 0 0. So we will be keep on getting after decimal point 0 0 0. 47 minus 4 is 43. So that means what you will get? 47 minus 4. So this will be 90x is equal to 43. Now x will be what? X will be 43 divided by 90. So when we converted 4.7 bar into P by Q form, what we got? 43 divided by 90. This cannot be simplified further. So this is the log method. Now we will be solving the same question with shortcut method. So see, 0.47 bar. So what is the method I told? The digits, so only above one digit bar is there. So how many 9 will come? 1 9. Now here one digit is there where above the digit bar is not there. So that is why in the denominator you have to write 0. Now the number you write 47. Now you see, above the 4 bar is not there. You have to subtract the number or the digit, you have to subtract the digit where above the digit bar is not there. Means you have to subtract the digit which does not contain bar. So if one digit does not contain bar, then this one digit you have to subtract. If the two digits does not contain bar, then you have to subtract the two digits. So you will get 43 divided by 90. So this is the shortcut method and this one is the long method. So you should know both the methods because both the methods will be useful. If the question comes in the form of MCQ, you have to apply the shortcut method. If the question comes for 2-3 marks, then you have to apply the long method. Now let's see the next question. 0.001 bar. Now here you see above the 3 digits bar is there, and here there is no digit which does not contain bar. All the 3 digits bar is there. So let x is equal to 0.001 bar. So x is equal to 0.001, 001, 001 like this. Now you see here above the 3 digits bar is there, no? So directly we can multiply both the equations by 100 because above 3 digits bar is there, and there is no digit which does not contain bar. All the 3 digits contain bar. So multiply both the sides. Okay, sorry. If above the 1 digit bar is there, then we have to multiply with the 10. If above the 2 digit bar is there, then we have to multiply with 100. If above the 3 digit bar is there, then we have to multiply with 1000, not with 100. So if you multiply both the sides by 1000, what will get? This will be 1000x, and this will be what? These 3 digits will be coming before the decimal point. This will be 001.001, 001, 001 like this. Now here you see we got the two equation, this equation and this equation. In both the equation, after decimal point the digits are same. Here also after decimal point the digits are same. Here also after decimal point the digits are same. So we can consider this one as the equation number 1 and this one as the equation number 2. Now we will be subtracting the equation 1 from 2. So we can write equation 2 minus 1. So what will get? 1000x minus x. 1000x minus x is equal to, this will be 001.001, 001 dot 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 minus 0 point like this. Now you see 1000x minus x is 999x is equal to, here what is there? 1.000 like this, 0 point this. So if you subtract this, what will get? 1. So this will be, x will be equal to 1 divided by 9999. So if we converted this 0.001 bar, then what you will get? In the p by q form, 1 divided by 999. So this is the long method. The same question will be solving with shortcut method. You see the question is 0.001 bar. So you see, I told no, if above the 1 digit bar is there, so 19 you have to write. If above the 2 digit bar is there, that 29 you have to write. Here you see above the 3 digits bar is there. So that is why we have to write 39. And here all the digits contain bar. And there is no digit which does not contain bar. So there is no need for subtraction of the number. So this will be 1 divided by 999. So this is the shortcut method and this is the long method. Now see the next question. Next question is 0.54 bar. So here both the digits 5 also 4 also, both the digits contain bar. So let x is equal to 0.545454 like this. Now here you see there is no digit which does not contain bar. Only 2 digits are there and above both the digits bar is there. So directly we can multiply both the equations by 100. Multiply, sorry, not equation, both the sides. Multiply both the sides by 100. So what you will get? 100x. So if you multiply, two digits will come before the decimal point. This will be 54.5454 like this. So this will be 100x is equal to, okay. Now here you see both the equation you observe. In this equation also after decimal point the digits are same. In this equation also after decimal point the digits are same. So we can consider this one is the equation number 1 and this one is the equation number 2. Now we subtract the equation 1 from 2. So or in short we can write equation 2 minus 1. So see this will be 100x minus x and this will be 54.5454 minus 0.5454 like this. So 100x minus x is 909, sorry, 99x and 54 minus 0 is 54. So this will be x will be equal to 54 divided by 99. So 5 plus 4 is 9. So both the number is divisible by 3. This will be 3 ones are 3, 3 eights are 24. This will be 33, 3 6 are 18, 3 11s are is 33. So what we got? X we got 6 by 11. Now this is the long method. Again this question also can be solved with the help of shortcut method. So you see above how many digits bar is there? 2 digits. So in the denominator 2 9 will come. Now you see both the digits contain bar. So the digits, there is no digit which does not contain bar, so no need to do subtraction. Now simplify. This will be 18 3 is 54, 33 3 is 99, 3 6 are 18, 11. Same answer we will get. Whether we will do the long method or the shortcut method, same answer we will get. Now the last question is 0.59 bar. 0.59 bar. Now in this question you see one digit contain bar and one digit does not contain bar. That means only the 9 is repeating but the 5 is not repeating. So if this kind of question you are getting, don't multiply by 100. First you multiply with the 10, then again multiply with the 10. Then you find the two equations where after decimal point the digits are same. Then you subtract the one equation from another and you will reach to the answer. So let x is equal to 0.59999 because only the digit 9 is repeating. Now multiply both the sides by 10. So here what we'll get? 10x is equal to one digit only will come before the decimal point, 5.9999 like this. Now you see here two equations are there but after decimal point the digits are not same. So in this case what you have to do? We have to multiply again by 10, both the sides by 10. Again multiply both the sides by 10. So this will be 100x and this will be 59.9999 like this. Now you see we got the two equation where after decimal point the digits are same. So this equation and this equation. So we can consider this as the equation 1 and this as the equation 2. Now subtract the equation 1 from 2. Equation 2 minus 1. So what we will get? 100x minus 10x is equal to 59.9999 minus 5.9999 9999. So this will be 100x minus 10x is 90x is equal to 54. Sorry, 59 plus 5 is 54. Now x is equal to 54 divided by 90. Again, both the number is divisible by 3. So 5 plus 4 is 9. So 3 18s are is 54, 30, again 3 6, 3 10, again 3 2 jar is 6, 5 2 jar is 10. So you will get 3 by 5. So 0.54 bar. Sorry, 0.59 bar. So if we convert in the P by Q form, what we will get? 3 by 5. So this is the long method. Again, we'll be solving this with the help of shortcut method. So see, 0.59 bar. So above how many digit bar is there? 1 digit. So in the denominator, 1 9 will come. Now you see, 1 digit is there which does not contain bar. So that is why 1 0 in the denominator we have to write. Now both whatever number will be there, that number you have to write. 59. Now we have to subtract the number. Sorry, we have to subtract the digit or the sets of the digit which does not contain bar. So this will be 54 divided by 90. Again see, if we simplify, we will reach to 3 by 5. So in this way we can solve any non-terminating repeating decimal expansion in the form of P by Q form. Okay, now let's see this question number 5. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 7? So this one is very easy question. You can perform by yourself. Just you have to divide 1 by 17 and you have to check after how many after how many digits the digits will be repeating. So see, if we perform the division 1 divided by 17, so see, just divide by 17. So 0, 0, 100. So 17 5 times is 85, 15, 0, 17 8 jar is 136, 14 0, 17 8 jar is 136, 4 0, 17 2 jar is 34, 6. So like this, if you divide, you will be getting the 16 digits. You will find the 16 digits will be repeating. So this is a very long division you can perform at home and you can try. So you will find that the 16 digits will be repeating. After 16 digit you will be getting again 5, 8, 8, 2 like this. So this one you can perform and you can check by yourself. Okay, now let's see this question number 6. Look at the several examples of rational numbers in the form of P by Q, where P and Q are integers with no common factors other than 1 and having terminating decimal expansion. Means we have to write some examples of the rational numbers whose decimal expansion will be terminating. So if we can write these examples, then we have to check the denominator, that is the Q. Q satisfy what condition? So let's see. First let's write some of the examples of the rational numbers which will have the terminating decimal expansion. Let's suppose if I write 1 by 2. So the decimal expansion of 1 by 2 will be 0.5. So if I write 1 by 4, this will be 0.25. So if we write the decimal expansion of 1 by 8, so this will be 0.125. Let's write some more example. If I write 1 by 5, the decimal expansion will be 0.2. So if I write 1 by 25, the decimal expansion will be 0.5 4 20, 0.04. Okay, now see, if we divide 1 divided by 10, this one 0.1, 1 divided by 100, this will be 0.01. Now see, whatever examples I have written, the rational numbers example, all they have the terminating decimal expansion. This is also terminating, all this example of the terminating decimal expansion. Now we have to see the denominator, that is the q. This is q. So this q is satisfying what condition? So that whatever examples I have written, all they have the terminating decimal expansion. So here you see, these two I can write 2 to the power 1. This 2 how we can write? 2 square. This 8 how can I write? 2 to the power cube. This 5 also I can be written as 5 to the power 1. This 25 also can be written 5 square. Now this 10 how can I write? 10 to the power, sorry, 2 into 5. 2 to the power 1, 5 to the power 1. Now this 100 how can I write? 4 into 25. 4 25 that is 100. So this can be written 2 to the power 2. 2 square is 4 and 25 can be written 5 square. Now from this what we can conclude? We can conclude that if the q is 2 to the power something, 2 to the power something, anything, it can be 1, 2, 3. If that q is 2 to the power something or 5 to the power something, or we can say that if the q is 2 to the power something, 5 to the power something, then also the decimal expansion will be terminating. So three condition is there. So see, the q can be 2 to the power something. Here m means any number. It can be 2, 3, 1, 5, anything. Or the q can be 5 to the power something. It can be alone 2 to the power something. It can be alone 5 to the power something. Or it can be 2 to the power something into 5 to the power something. Here you see the 2, here m written, n written. That means here these numbers can be different also. 2 to the power something, 5 to the power something. If the q satisfy these three conditions, then only the decimal expansion always and always will be terminating. So see, the denominator can be either in the form of 2 to the power something or 5 to the power something, or the combination of 2 to the power something, 5 to the power something. This condition has to be satisfied to become a rational number as terminating decimal expansion. Let's see this question number 7. Write three numbers whose decimal expansion are non-terminating, non-recurring. So we know that all the irrational numbers, their decimal expansion are always non-terminating, non-recurring. So we can write any numbers in such a way that the decimal expansion should be non-terminating, non-repeating. So infinite examples can be written. So for example, one such number is, example we can write 1.23921001236782. So like this. So only thing you have to be careful that the digits should not be repeating. Any one digit or two digit, there should not be the repetition of the digits. Or we can write 295623678001200139 like this. Or one more we can write anything to. So these are the decimal point. 567892001122369. So like this we can write there are infinite number of the number whose decimal expansion is non-terminating, non-recurring. So these all are examples of the non-terminating, non-recurring decimal expansion. All are irrational numbers. Now let's see this question number 8. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So two rational numbers are given. One is 5 by 7 and one is 9 by 11. So we have to find out the three irrational numbers between these two numbers. So let's see how can we calculate. So first divide these two rational numbers 5 by 7. So if we divide 5 by 7. So decimal point 0. 7 sevens are 49. 1 0. 7 ones are 7. 3 0. 4 sevens are 28. 2 0. 7 twos are 14. 6 0. 7 eights are 56. 4 0. 7 fives are 35. 5 0. Then 7 sevens are 49. So we will find that if we divide 5 by 7, we will get 0.71428.5. And after this 5, again there will be the repetition of the digits. Now similarly, we will divide 9 by 11. So 9 divided by 11. So what we will get? 0, 8 11s are 88, 2 0, 11 ones are 11, 9 0, 8 11s are 88, 2 0, 11 ones are 11. So this decimal expansion will be non-terminating but repeating. So here we can see the repetition of the digits. So what digits gets repeated? 81, 81, 81 like this. So this one we can write 0.81 bar. That means these two digits will be repeating. Now we have to find out the two irrational number between this number and this number. So see, we can write the infinite number of irrational numbers between two rational numbers. So anything, let's suppose you see, we have to write the number between 0.71 and 0.81. So we can start like this: 0.723969000123. So only you have to be careful that there should not be the repetition of the digits. So like this we can write the irrational number. And one more we can write 0.759230001000239006. So this is the second number. So one more we can write 0. Let's suppose 792392. Just we can observe the first two digits. So see 0.72, it will lie between 0.71 and 0.81. This also 0.75, it also will lie between 0.71 and 0.81. So like this we can write the infinite number of irrational numbers between two rational numbers. Okay, now let's see this question number 9. Classify the following numbers as rational or irrational. So 5 examples are given. We have to identify which one is rational and which one is irrational. So already we know that uh, all the imperfect square root is an example of irrational number, or the decimal expansion is non-terminating as well as non-repeating. This is also example of the irrational number. And how can we identify the rational numbers? The perfect square root or the decimal expansion, if it is terminating, then rational number. If it is non-terminating but repeating, then also it is an example of the rational number. So let's find which one is rational and which one is irrational. So the first question is square root of 23. So here clearly we can see that this root 23 is an imperfect square root. Since it is an imperfect square root, hence it is an rational number. Sorry, it is an irrational number. Now the second question is root 225. So root 225 is a perfect square root. This is the square root of 15. So if we do 15 into 15, we will get root 25. So since it is an perfect square root, so that is why root 225, it is an example of rational number. Now The question number third. 0.3796. So here also clearly we can see that after decimal point the digits got terminated. So it is since the decimal expansion is terminating decimal expansion. So that is why it is also an example of rational number. Now the number 4. 7 point, here you see 7.478478 like this. So here clearly we can see that these three digits are repeating. So 7.478 bar. So since the digits are non-terminating but repeating, so that is why it is also an example of rational number. Now the last question check. See 1.10, then again 20 is there, then 30, 40, but there is no repetition of the digits. Like this repetition is not there, nor the single digit or the set of the digits are repeating. So since the decimal expansion is non-terminating as well as non-repeating, it is an example of irrational number. So this was the last question from our exercise 1.3. Thank you for watching.